Hello, hello once again. My name is Alfred, and welcome to my visual demonstration for my second exercise, that is the mutual exclusion, and one among them is the banker's algorithm. And this is the second exercise of the Advanced Operating Systems Laboratory series. So moving on, the banker's algorithm is used to determine whether a system is in a safe state or not. Now, the banker's algorithm is simulated by three major inputs, and they are taken as the following data structures as shown here below, each of them in a matrix format. So we have an m cross n matrix, two-dimensional matrix format, and that's how we are taking these three variables, that is max, allocated, and available, and also an additional matrix called need that is going to be specified in a question that we're going to solve right now. So moving on, we have the algorithm. So this is the algorithm, noting that P is a set of processes, MP is maximal requirement of resources for process P, and CP the current resources for P, and A is for available resources. So moving on with the algorithm, this is how the algorithm looks like. While P is not null, the following operation takes place. So if for each P belongs to P, and if in case it is false, and if that's found, the following operation occurs, that is MP minus CP, that is MP is the maximal requirement and the current resources. That a maximal requirement minus current resources, and that is less than or equal to the available resources, A. So the following occurs. A available resources is added with the current processes, and the process in particular, that's P, set of processes have its own subset of processes that is decremented, and that has been found to be true. Else, it breaks out of this, this control. The control breaks out of this block and enters. If not found, then you should print you should display that the system is not in a safe state. Otherwise, if this is found to be true, then it returns that it displays the system is in a safe state. So that's all about the algorithm, and then we move on to the program. And hereby I'm going to show you how this program works, and the subsequent outputs are obtained. So this entire thing is typed in Java. So I'll show you the program. I'll run through the program once. So this is where you're taking the inputs for max, need, and allocate, and available resources. So here we are just allocating the resources in this matrix format. Moving on, we are entering the allocation matrix right here, max matrix, available matrix, and then moving on with another user-defined function where we have to calculate the need. So this is for calculating, this entire control is for calculating the need. The main formula is within a nested for loop of I and j. That's because we are using a matrix. That's the reason why. So need ij equals max ij minus allocate ij. So that is the main formula. And then this function is for checking. It's just a simple check that we are performing whether a system is in a safe state or not. And moving on, we have this another function that's checking whether it is in a safe state or not. So that way, you're moving forward in a loop. That's how I've written this code. You're moving forward. You're not backtracking as such, and then again performing the same operation with this formula. Avail resources equals avail minus need plus max. And then moving on by displaying the allocated processes as such, and then printing whether it's safely allocated or it can't be allocated safely. that way. So the entire execution starts from this block, that is the main function, and from here it calls isSave function. It goes on here, and then the flow of control comes here. That's what I meant. And then we have other functions called input and calculate the need. The need matrix is calculated, having given the need, or the need is given as such. So and so on and so forth with the other functions like check, and that's it. And then it just, the flow of control goes to these user defined functions that I've defined here, and then moving on with the input. I mean, first, as obvious it would be, like, you're just scanning the inputs, so you're reading it from the keyboard, so that's what the inputs are for in this function, and then the calculation has taken place over here. So moving on, without further ado, let's compile and run this program. Just maximize the console. So I'll just feed in the inputs. Moment. Okay, so here we are. I have written the so here is what we have to be shown for the now it's asking the number of processes and events. So I have, looking at this metrics format over here, we have an m cross n matrix that has 5 processes starting from P0 to P4. So any way you can number them up. So you have 5 processes with 3 events subsequent to it. So I'm going to enter 5 processes and 3 events. Alright. I'm going to enter the allocation matrix, that is 0, 1, 0, and then 2, 0, 0, 3. Oh, I gotta redo it. Okay. 5, 3. So allocation matrix, I'm going to enter these values as you can see on the screen here. Okay, and the available matrix, that is 3, 3, 2. So here we are. This is the output that I got. I'm going to close this and save. So here we are. This is the output that we got. It's compiled in between. So for the first process, when we were just checking the control flow, it was showing it was not in a safe state as available of ij was greater than need of ij. By manually just checking this out in each and every loop that it goes forward is where we get this output. And then finally, when this was less than the available resource, it moved on and just got one allocated process 1, and then 3, 4, 0, 2 in the subsequent steps as specified in the program. So this is the output, and that'll be the end of it. And thank you for watching this video. This is me signing off.